All right, champs, today we're going to continue our talk on linear functions. Remember, this whole unit our goal is to be able to graph lines in different forms and recognize characteristics of linear functions. So as you can see at the top, we're going to be talking about slope today, reviewing what that is, and then talking about another form of a linear function called slope-intercept form. Yesterday, we didn't focus on any specific form. We just focused on finding x and y intercepts. That is a skill that you can use with any form of a linear equation, and it's super helpful to remember. And we'll continue practicing it today along with our new form, which is slope-intercept form. So at the end of today's lesson, you should be able to both find slope of a line and graph a line in slope-intercept form. Let's try out this warm-up up at the top, a little word problem to get us started. Will got his car towed. Womp womp. The towing company charges a flat fee of $75 plus $10 per hour the car sits on the towing lot. We want to write an equation that models the total cost of towing. So let's first figure out what X stands for and what Y stands for. What is driving the change in the cost? The number of hours that the car sits on the lot. The number of hours that the car is on the lot is going to affect Y, our output, which is the total cost. See if you can write an equation that allows you to find the total cost, given that the flat fee is $75 and it costs $10 per hour to sit on the towing lot. I'm going to pause the screen. You should come up with an equation of Y, the total cost, is equal to the $75 flat rate fee, plus $10 per hour. Per, remember, means multiply. $10 times the number of hours that the car is on the lot. Oh, we just found what the X represents, and the Y is the same thing as f of X. It's the total cost. Now, if we wanted to find the y-intercept, like the next part of this problem is asking us to find, remember from yesterday, if we want to find the y-intercept, where the graph crosses the y-axis, which variable are we going to set equal to 0? Hopefully you remember we set x equal to 0. So we go back up to the top. We have 75 plus 10 times 0 would just give us 0, so it's just 75. So our y-intercept is 0, 75. Now think about contextually what this represents. Remember, this is our x, this is our y. Our x stands for the number of hours on the car lot. So if it is 0 hours on the car lot, it is going to cost $75. So you can kind of think about it like the flat rate fee that you're going to pay for the towing. You can call it the flat fee, or you can say the cost of towing, spending 0 hours on the lot. Let's move on and review what slope is. By the way, the form that we wrote this in might come in to play later on. So slope is a part of slope-intercept form. Every linear function has a slope. Slope, not is if the, but is the rate of change of the line. It's the rate of change. It tells you how steep or how shallow a line is. Now, you'll need to remember that, oops, I left the E off change. This is a formula that you'll need to remember in order to find the slope of a line. So slope, for whatever reason, I know that slope has no m's in it, but the variable in math that is used to represent slope is m. It is the change in your y variables over the change in x. Now this order here matters. Change in y over change in x. This delta, this triangle here, is just another way of saying change in. So it's the change in y over the change in x. To find the change in a variable, you take 2 points on the line, subtract the y values. So y2 minus y1, one of the y values minus the other, over x2 minus x1. And last but not least, you might refer to it as the up and down versus the right and left, or the rise, how much the graph goes up, versus the run. So let's work on finding the slope of this graph to the right. The first thing you're going to need to find are two clear points that go through a corner of a square. So for example, I could use this point, this point, this point, any of these points that go through the corners of a square. It doesn't matter which two you use. You just need two. So to find the slope, we're going to find the rise, or the change in the y's, over the run. So it's the change in y over the change in x. Start on your leftmost point down here. As we go from this 30 up to get to our next point, look at the scale and how much we change. As we go up, we're changing by 5. Up is a change of positive 5. If we went down, it would be negative 5. Similarly, we go to the right to get to that next point. Look at your scale down here. That is a change of 1. So our slope is 5 over 1, or 5. Again, the variable m is often used to represent slope. When it's asked us to find out what this represents, it means in the context of this problem. So this problem is talking about saving money. Now let's go back and look at this 5 over 1. The 5 is the change in the y value, the 1 is the change in the x. What is changing on the y-axis? If you look on the y-axis, it stands for the amount of money. So that is gaining $5 since it's positive 5. So it's up $5 every, look at what this x-axis represents, weeks. So he saves $5 every week. You'll notice that in a linear function, that slope is not changing over time. There is a constant rate of change. The slope stays constant. Let's go down to the bottom, and these are not any context, but we're just going to practice finding the slope. Remember, it's the rise over the run. Start at your left point. We're going to our right point. As we travel up on the y-axis, you'll notice we go up 2. That is positive 2. We go right, 3. So the slope of this line is 2/3. 2 over 3. Let's say you went from this point, this topmost point, to this bottommost point. You would go down 2, and you would go left 3, negative 2 over negative 3. That's still the same, 2/3. So it doesn't matter if you start at the left or the right point, just make sure that you're paying attention to your signs. Let's go over to our next one. Find two ordered pairs that go through the corner of squares. Here's one. Here's one. Find out how much you rise to get from point to point. This went up 6. And then how far left we went. Went left 4. So up is positive, left is negative, and then simplify to negative 3/2. Try the last one on your own. You should have gotten a rate of change of 3/2. We do not write that as a decimal or as a as a mixed number. We leave it as an improper fraction when we're dealing with slope. Let's check out the next page. I think the word slope formula got cut off on the page before, but if you want to find the slope of a line, you find the difference in your y's over the difference in your x's. Oops. It does not matter which point is x1, y1, and which point is x2, y2. You just label as needed. So let's make this one x1, y1, and this x2, y2. So if we want to find our slope, we're going to subtract our y's first, 0 minus 2, And then we keep that order consistent. So I did 0 minus 2. So now I've got to do negative 3 minus 9. 0 minus 2 gives us negative 2 over negative 12. Simplify that to get 1/6. So the slope of that line is 1/6. Meaning, if we went from point to point on this line, we go up 1 over 6, up 1 over 6. Try the one beneath it using the slope formula. Label your points, x1, y1, and x2, y2. The order that it is necessary that you put the change in your y's up top. So this is the difference in my y's over the difference in my x's. Got 6 over negative 12, which simplifies to negative 1/2. Always make sure you simplify that fraction. Now let's look at these two unique scenarios underneath here. Oh, by the way, on that last one, if you had a slope of negative 1/2, that means that you would be going down 1, right 2, down 1, right 2, down 1, right 2 to get from point to point. Remember, negative slopes fall across the graph. Positive slopes, like the one up above, rise as you're looking from left to right. So falling is negative, rising is positive. These two unique scenarios down beneath here, we have a completely horizontal line and a completely vertical line. So this is a horizontal line. Horizontal lines are horizontal like the horizon. The horizon is where the sun sets. Vertical lines are lines that go completely up and down. The slopes of these lines are considered unique. Think about as we went from point to point here on this horizontal line. How much are we rising as we get from the left point to the right point? We're rising 0. Our slope is then 0 over, for example, in this case, 2. 0 divided by 2 is 0. The slope of a line that is horizontal is 0. So if you have a horizontal line, the slope is 0. On the other hand, if you look to the guy to the right, this vertical line, let's just find 2 points. Find how much you're rising as you go from those 2 points. We're rising 2. How much is our x changing? 0. When you have 0 in the denominator like this is called undefined. This kind of slope where you're up and down, a completely vertical line, we'd say our slope is undefined. I can't attach it to this video, but you should definitely look up Slope Dude on YouTube to help you remember your different types of slope. The way that I always teach kids to remember these unique situations is Hoibucks. Let me erase this right here. Try writing this in the middle. Hoibucks. H stands for horizontal. The O stands for it has a slope of 0. The Y stands for it's always going to start Y equals. So for example, this line over here is Y equals 3. There's not going to be any X involved. So horizontal, 0 slope, Y equals. Bucks, on the other hand, the V stands for vertical. The U stands for an undefined slope. And the X stands for it's always going to start out X equals. So for example, this line over here is the equation X equals 3. Vertical lines, you know you'll see them when you just have X equals a number. You go to that number on the X-axis and draw a vertical line. So that is a helpful little tool to help you remember your unique situations if you want to cloud that up on your notes. Now that we've reviewed slope, let's get into slope-intercept form, which is one way that you can graph a linear function. Slope-intercept form is probably something that you remember touching on in years past. It looks like this. Y equals mx plus b. It's just the order that a linear equation can be arranged in so that you can graph it easily. The m represents the slope, and the b represents the y-intercept. Remember, it's the y-intercept. So when you're graphing a line in slope-intercept form, it's very basic. You first plot the y-intercept on the y-axis, so whatever that b value is. Then you figure out the, I think that's just supposed to go in there, slope of the line. Remember the directions of the slope. Rise over run. So the top number tells you the up and down, the bottom number tells you how much you go left and right. If it's a whole number, you can always stick it over 1. So if your slope was like 5, stick it over 1. You get 5 over 1, so you can see your rise and your run. Use your slope to find additional points, and then you connect the points. Let's give it a shot with this first example. First things first, we're going to find our y-intercept. Remember, this is y equals mx plus b. Our b value is the y-intercept, so it is 0, 3. Go ahead and plot that. Then you're going to find your slope. Our slope in this case is in front of x. It is -2. That is a whole number. Stick it over 1. The rise is on top. The run is on the bottom. This rise is telling us to go -2. That means we go down 2. +1 tells us to go right 1. So we're going to go back to our y-intercept over here. Go down 2, right 1. Down 2, right 1. Down 2, right 1. Continue that across your graph until you've got enough points to make a straight line. And now you've graphed it using the slope-intercept form. Let's continue to the right. Find your y-intercept first. It's the constant, the number that stands alone. You'll notice that this -4 is out in front. That goes with that number. So it's 0, -4. Find the slope. That's the number in front of x, 2/3. The rise is on top. It's a +2. So is that telling us to go up or down? Up 2. The run is on the bottom. It's 3. It's telling us to go right 3. So go to your point. Go up 2, right 3. Up 2, right 3. Or down 2, left 3. Connect your points. You'll notice for a second that this line has a positive slope, and notice how it's rising across the graph. The one before had a negative slope, and it is falling across the graph. Now, on this back one, I want you to try to write the equation in slope-intercept form. So we're going in backwards order. Y equals mx plus b. You need to know your slope. You need to find your y-intercept. Find your y-intercept first. You'll see that is -2. Find your slope by finding another point that goes to the corner of a square. Find your rise. Put it over your run. We rise 3, run 4. Is this a positive or negative slope? You should recognize it's rising across the graph, so that is a +3/4. So you have y equals 3/4 x minus 2. Y-intercept at -2 down here. Slope is up 3/4. Try the same skill with the next one. Double check that you found that the y-intercept was 3 and the slope was -1. Remember, it's -1 because you're rising 1, going up, and then going left 1. Or you can recognize that this graph is falling as it goes across the page. That is always going to have a negative slope. Let's go ahead and plug those in. We have y equals, your m value is -1, x plus 3. Now, you never will see a -1 written there. It's like an understood thing. So we would write this as -x plus 3. If you wrote -1x, it's not wrong, but you just won't see that. All right, last thing we're going to go over is how to write an equation in slope-intercept form when you're given 3 different scenarios. So if you're given the slope and the y-intercept, it's easy as pie. You're given the slope, m. It's -1/2. That goes to the point 0, 10. Well, notice if the x value is 0, y value is 10, that is our b value, our y-intercept. So you'll simply plug in y equals -1/2 x plus 10. If you're given a slope and a random point on the line, so this is our slope, and it passes through the point 12, 9, that is not our y-intercept. That is just an x and a y that's on the line. So first thing you're going to do is you're going to plug in your x, your y, and your b into this equation. So you're going to have these 3 variables. And then you're going to solve for m. Let's give it a shot. Our y value is 9. Our slope is 3/4. Our x is 12. We don't know b. So we have 9 equals, stick this 12 over 1. 3 times 12 is 36. 4 times 1 is 4. What's 36 divided by 4? 9. Solve for b by subtracting 9. We get b equals 0. So now we know if we're plugging into y equals mx plus b, we know our slope, we know our y-intercept. So we have y equals 3/4 x plus 0, which we don't even have to write. You can just write it as y equals 3/4 x. The final type, when you're given 2 points, means we're missing both things. We might be missing the slope, and we are missing the slope, and we might be missing the y-intercept as well. So you're first going to find the slope using your slope formula. Remember, it's the change in y's over the change in x's. Then plug your x, your y, and your slope into y equals mx plus b to find your b value. Now look at these points, We have 1, 3, so that's an x and a y, and we have 0, 9. Something should ring in your head about this 0, 9. That is our b value. We got lucky here, that's our y-intercept. So all we need to find is our slope. So we're first going to find our slope. Subtract your y's, so let's do 9 minus 3. I went in this order, so I'm going to keep that up. So I have to do 0 minus 1. 9 minus 3 is 6. 0 minus 1 is negative 1. We get our slope as negative 6. And second, we will plug into y equals mx plus b. So we have y equals, our slope was negative 6. X plus our b value we found up there was 9. We got kind of lucky with that one. Let's look at this one beneath here. In this one beneath, we have our points, 2, 3, and another point, negative 4, 9. First thing we need to find is the slope. Change in y's over your change in x's. So I'm going to subtract the second y minus the first y, the second x minus the first x. You should get that the m is negative 1. In our second step, we're going to plug in one of the points. It doesn't matter which one, x, y, and m. And we're going to find b. Let's try that out. I'm going to use the point 2, 3. Doesn't matter which one you use. So we're plugging into y equals mx plus b. Our y value is 3. Our m value is negative 1. X is 2. We don't know b. Add 2 to the left side, and you should get b is 5. In your third and final step, you now know your b value, you know your m value, so you have enough information to plug into slope-intercept form. So you should have y equals negative 1x, or just negative x, plus 5. If you plugged in this other point, negative 4, 9, in this step, then you would get the same thing for b value. It does not matter which point you use. You'll eventually get this as the equation of your line, which would mean we're going up 5, and you have a slope of negative 1. So it looks something like that. All right, give your homework problems a shot. Rewatch anything on here if you have questions.